In this review, let's talk about problem 4.1 in the certification review. We have a unit circle and a ray emanating from the origin, and the question is to figure out these four trigonometric identities. The first two are easy. When you have a unit circle and a ray comes from the origin, then the cosine of the angle in standard position is the x-coordinate of the point on the unit circle where they intersect, and the y-coordinate is the sine of the angle. And so automatically we know that cosine of theta is 0.8, while sine of theta is 0.6. For part 3, there's a couple of ways of doing this. Let me first show one way to not do it. First thought might be to try to use the addition formula for tangent. So tangent of the first plus the tangent of the second. All over 1 minus the tangent of the first times the tangent of the second. And as I write this down, the reason that this is a bad idea is because tangent of pi over 2 is undefined. And so there is an answer for this, but I cannot use this formula to get it. So this is the incorrect approach. Another approach, which works, though I don't particularly recommend it, is to write it as sine of the top, sine of the angle, divided by the cosine of the angle. And then we use the addition formulas for sine and cosine to expand out the top and the bottom. So it will be sine of the first times the sine of the second, or sorry, times the cosine of the second, plus the cosine of the first times the sine of the second. So that's the numerator. The denominator would be the cosine of the first, cosine of the second, minus the sine of the first times the sine of the second. Okay, now this simplifies considerably. Cosine of pi over 2 is 0, so both of those disappear. For the terms that are left, sine of pi over 2 is 1, so multiplying by 1 doesn't improve anything. And so we're left with simply cosine of 0, which is, cosine of theta, which is 0.8, divided by negative sine theta, which is negative 0.6, which then simplifies as negative 4/3. And so the answer for the third one is negative 4/3. So that's one way to get it. I don't particularly recommend it for this problem because there's an easier way to get it. And the easier way to get it is to literally add an extra 90 degrees so that this is a right angle. And so the angle in green here is theta plus pi over 2. Then the point in red here, 0.8 to 0.6, gets rotated over 90 degrees. And clearly the coordinates at this point are going to be 0.6, or negative 0.6, comma 0.8. The x-coordinate is negative 0.6, and the y-coordinate is positive 0.8. And that matches what we saw in the fraction here. The sine is positive 0.8, the cosine is negative 0.6, and then dividing again we get negative 4/3. For the fourth problem, again, we could use the difference formula for sine. The easier way to do it is to literally subtract pi, subtract a half rotation away from theta, so that this becomes theta minus pi over 2. And so this point on the unit circle is going to be the reflection through the origin, which is negative 0.8, negative 0.6. And so the sine is going to be the y-coordinate of that new point, and the y-coordinate is negative 0.6. And so that's how to do this problem.